Hello and welcome to our third tutorial movie about how to get the most from SeedX's AI-powered seed breeding tools. As we've discussed previously, GeNee Envision can be used as an integrated part of your breeding program, as part of your seed production pipeline, or if you're in the food industry for advanced QA analysis, traceability, detection, and more. In this tutorial video, we're going to explore how to use GeNee Envision to detect coffee bean quality. Here, Envision has generated a world for Arabica coffee. By world, we mean the image acquisition from a set of different coffee beans lines, representing the genetic and environmental variation of the coffee diversity. This world of Arabica coffee beans was built based on images of 8 different batches of the same Arabica line. It includes lines with high quality and some with lower quality. Typically, bean image information for AI and machine learning produces multi-dimensional outputs that are hard to represent in a visual scheme. For ease of use, SeedX reduces the information to just 2 dimensions. Each dot represents one bean, and each different color represents a different line. The scale in the scheme represents the overall distance between the dots. The closer they are, the closer the beans are. Let's break this chart down to get a better idea of what's happening in the results. Line 5, represented in the light blue color, was grown in a unique area characterized by very high-quality beans. As you can see, this line is separate from the other lines. We can see that this is very useful for traceability analysis, as you can detect if all the dots, that is, beans, are grouped together or are located in a low-quality beans area. In this group of lines, we can see 2 different patterns emerging for the low-quality and for the high-quality lines. Let's highlight the high-quality lines. And now the low-quality lines. If we look at both groups together, the low and the high quality, we can see that there is some overlap between the groups, indicating beans of medium quality. Nevertheless, there is a clear separation of quality levels. Now, let's take a new line, line 91, represented by the purple dots. We can see that this line is spread among both the low-quality and high-quality coffee beans. We can also separate the beans into these 2 categories. These categorized beans were sent back to the coffee company for evaluation, and our results were successfully validated. Now let's take a look at this information on the circles distribution. These circles represent the variation within each coffee beans lot. Here we can clearly see that line 91 has a very large variation compared to the other lines. Based on the training we have done for the quality groups, we can sort the coffee beans into high quality and low quality. Now that we have these 2 groups, we can move on to better understand the physical parameters related to high fermentation, which is one of the measurements for quality. One of the most dominant parameters is the actual bean color. Among the parameters that GeNee Envision measures are the RGB spectrum. The blue color dots in this chart represent beans where quality is significantly higher compared to the low-quality beans. However, because there is some overlap between the parameters, we can ascertain that color alone is not sufficient for separating these coffee beans. In this box plot, we can see that the perimeters of the beans are almost the same. Having a better understanding of the coffee beans' physical parameters should help us in our future QA analysis. For example, now that we understand that the red color is related to beans quality, we can use it as a marker for new lot quality. Of course, for even richer analysis and for sorting, we will need to harness the full capabilities of the GeNee Envision platform. We will explore this in a future tutorial video. As we've just demonstrated, by using the GeNee Envision, you now have the visibility to quickly and easily improve quality analysis for coffee beans, making sure that only the best quality coffee beans end up in your morning cup of coffee.